So let's say that we formed, let's say we have a lens that forms it's a mirror. We have a mirror. Can't make up my mind. A mirror that forms only virtual images. Radius of curvature is 3 meters. I guess that would be a pretty big mirror. Let's find the focal length. A mirror that forms only virtual images. The radius of curvature is 3 meters. Let's find the focal length.
So, can we use that equation since it's in here?
Okay. Yeah, sounds good.
R equals 2F.
Sounds good. What's your answer then?
So it's a virtual image, which makes it negative. The focal would be negative. Yeah, -3.
Okay. I think there might have been a misstep in your logic there, but the most important thing is that you thought about the sign. Most people just plug into this formula and assume it comes out right. So actually, we shouldn't even write the formula like this. We should write it like this. This formula only tells you the magnitudes. It just says that the magnitude of r equals 2 times the magnitude of f. So we can use dots to show these are magnitudes or absolute values. So all that we really...
because it's diverging, not because it's virtual.
There you go. And how do you know it's diverging?
Because the mirror only creates virtual images, and that's what makes a diverging mirror.
Good, I think now we've got it. Okay, so all that we get from the formula is the magnitude of f. The magnitude of f is 3/2. And now it's our job to figure out f without the dot, the sign value. This is something we've seen many different times in physics. A lot of the formulas only give you magnitudes. It's your responsibility to put in the right sign. A lot of the formulas only give us magnitudes. We have to remember to put in the right sign. This r equals 2f only gives you the magnitude. As you said, the reason we can use this is that this is a mirror. This is only for mirrors. There is a formula for lenses, but it's more complicated. All right, so that gives us f equals 3/2. All right, and again, it only produces virtual images. That means it's got to be diverging, because diverging devices only produce virtual images, regardless of where you put the object. Like we talked about last time, I haven't even bothered to say f and 2f over here. It doesn't matter where the object is, it's always virtual. This can't be a converging device, because converging devices can be either real or virtual images, depending on how far you are. So we saw that diverging devices are actually pretty simple, or simplified in that case. So we got negative. All right, here's finally a case then where the careful people get rewarded over the less careful people, where the answer is negative. And I think almost everyone would get this wrong, because everyone doesn't understand the formula only gives us the magnitudes. A lot of people would say, oh, what an easy question. All right, you should think twice if you see such an easy question. Okay. All right, once again, this table kind of comes in handy, because otherwise we'd have to do a whole heck of a lot of algebra to say what type of device has a virtual image. We'd have to use that lens mirror equation. That would be a huge pain over there. So this is a big help here. Okay. Okay. Let's do a little ray tracing again. Draw the outgoing light ray here. Or, sorry. Okay, let's see if this is going to work. Okay, good. So when the light ray comes in parallel to the principal axis, the outgoing light ray, or its traceback, goes to the focal point. Okay, so far that's just review. By the way, in your homework, I think this is called the P ray, because it's parallel to the axis. All right, now try drawing the outgoing light ray here. Okay, good. Somehow this came out curved. It was supposed to be a straight line. I think I should start bringing a big ruler for this. Might actually be good to use a ruler for these.
Yeah.
Did I use a ruler on the test?
Yeah, we can use it really.
I never get things to converge here. Anyway, all right. I should have made a shorter focal length, then it would converge over here. So I think that's maybe a good key to make really short focal lengths in your picture. Let's say I just put the focal length here. Now they converge. Short focal lengths, that's the key. Okay. Okay, so this is another ray. Another good ray to draw is a ray that goes through the center of the device. And if it goes through the center of the lens, it's just a straight line that doesn't get bent. So you drew it correctly. You just draw a straight line that doesn't get bent. I noticed a common mistake. I guess maybe you're not making this yet, but some of my other students, oftentimes they think that everything goes to the focal point. Only this ray goes to the focal point. Only the ray that comes parallel to the axis goes to the focal point. No other ray goes to the focal point except the ray that came in parallel to the focal point, parallel to the principal axis, the horizontal axis here. The ray that goes through the center of the lens just keeps going straight with no bending. And there's a million other rays we could draw here too. We could draw a ray that's at all kinds of different angles, but none of them will go through the focal point except this P ray over here. Somehow a lot of people think that everything goes to the focal point. Okay. I said that obviously there's millions of different light rays that are going through this point. However, you really only need two. And these are generally the two that are most helpful. You should draw, I think the homework called this the M ray, because it's through the middle of the mirror. So the P ray and the M ray, the one that's where the incoming light is parallel to the principal axis, and one where the incoming light is going through the middle. You only need two rays, because that is all it takes to make an image. Remember, the image is where the outgoing light rays converge over here. You can see here we have an inverted image. My pictures never are clear enough to see whether things are really magnified or shrunk, but it's definitely inverted. All right. Also notice that usually when you're doing ray tracing, you just draw rays through the top of the object. You could draw rays through the bottom, but why bother? All we need is the ray through the top. And you put one side of the object on the principal axis, and you put this over here. All right, so last time we only went over these two rays, because that's all you need. However, what if the problem asks you about a different ray? Well, then you need to know about it. So there is at least one other ray we should go over here. So what's the other ray? The other ray is where the incoming light goes to the focal point. This is the ray where the incoming light goes to the focal point. Obviously, it doesn't get bent by the focal point because there's just air here. So it's just going to keep going through straight until it gets to here. I don't know if you remember or have any guesses about what's going to happen to it on the right-hand side. That's not a bad guess. Think about this ray. If you come in parallel to the axis, you go out through the focal point. So let's reverse that. If you come in through the focal point, you should go out parallel to the axis. And if this actually came out pretty good. It came out through the same point. I wasn't even trying. All right, very good, even without a ruler. Obviously, all the rays should be focused to the same point. The image is only in one point. If you do draw more than one ray, if you're drawing things to scale, everything should come through the same point here. Okay, so this shouldn't be too hard to remember because there's a kind of symmetry between the P ray and this ray over here. If the incoming light is parallel to the horizontal axis, the principal axis, then the outgoing light goes through the focal point. Well then, if the incoming light is going through the focal point, then the outgoing light is parallel to the axis. There's kind of symmetry there. All right, maybe this is called the F ray. I don't know. I don't know if this is called. Maybe we'd call it F because it goes to the focal point. I don't know if that has a name. I'm not sure about that. All right, they talk about that in your homework. Let's see.